To Marches for Makers. I'm Saran, and we have Scott Hanselman on the show as well. And this is our second video tutorial, and we're talking about 3D printing, which I'm really, really excited about. And Scott, you know a lot about 3D printing, right?
So the joke, actually, if you look at my website, I've got a blog post up that says that I'm an expert with 16 hours experience. So I would not say I know a lot.
That's 16 hours more than me. So in this dynamic, I think you're the expert.
Well, I appreciate that. I think that the thing that's fun about Marches for Makers, about everything that we're doing, is that we are all amateurs. It's just some of us are ahead of other amateurs a couple of weeks. I started 3D printing in the middle of January, so I am officially 2 months into it.
Nice.
So I'm getting started.
Wonderful. So we're going to do a walkthrough of some of the equipment and how it works and what 3D printing is, all that good stuff.
Yeah, absolutely. So I'll show you a couple of examples of what I printed, and then I'll show you what we use to do it, and then we maybe try some live printing, if that's cool.
Yeah.
So the boys, my sons, insisted that I print Groot.
I mean, you have to print Groot.
You have to print Groot. So that is actually pretty good size, if you see. It is extremely detailed, but it's actually mostly hollow. It's extremely light, weighs basically nothing. And if you look really, really close at Groot, let's see if we can get that to focus. Look at that. You see the lines?
Oh, look at the detail on that.
Yeah.
That's crazy.
Groot.
That's awesome.
Let's look at the bottom here. Do you see the lines that make up Groot?
Oh, I do. Yeah.
So let me give you an example of that's Groot's bottom. Let me show you one layer of Groot that's stopped halfway.
Oh, interesting.
So this is what's called filament. I'm using a thing called PLA, and it's a corn-based kind of filament. You see the lines there? Look at that. This one failed. You can actually see it kind of got all scratched up. It looks like the beginnings of a screen door, you know?
Interesting. Yeah.
And here's what it looks like in its natural format. You buy these filament deals here. These are what do they call this? A filament spool. And the filament looks like this. And then that melts around 200 degrees Celsius and then extrudes through a thermal tip. And that it extrudes through it. It's kind of like when you are squeezing the top of a cake to decorate a cake. It's the exact same kind of thing.
But I imagine it's a lot thinner, right? Like, would it be kind of more like a needle? Like,
yes, that's a great point. So what we'll do is we'll take some of this and we'll shove it through the printer, and we will watch it get smaller. This right here is 1.75 millimeters, but we'll get it down to 0.2 millimeters. Very, very, very small. So that base there of Groot, let me show you some failures. This is the other thing about 3D printing that you learn about, is that it's mostly failure.
Oh, no.
So here is, let's see if we can get that to focus. Get my hands to focus here. Webcams really want to focus on your face. All right, let's try that again. Hello.
Close. Almost. It's trying.
It's switched over to you, though. Hang on. Let me change the camera. Oh, let me switch to an alternative camera. 1 second.
No problem.
I'm going to pop over to camera 2.
Look at all those cameras you got.
Well, you got to be focused. And that one desperately wants to. There we go.
Yep.
It's like almost like a hair. Okay, but you notice that there's spaces in between them. They didn't melt together. See how you can see through them like a screen door? That should be solid, and it didn't end up solid. So I tried it again at a different temperature, and some of these melted. But
you still see some gaps.
And look, see, the tip was too close, and it pulled the plastic up.
Interesting. It's not flat.
So one of the things that's a challenge about this kind of stuff is it is a balance as you go between temperatures. Like, I've had prints halfway through a print, and the plastic is melting very nicely, and then the AC turns on, and then the ambient temperature of the room ruins it. But when things go well, then you get things like fun little boxes.
Oh, nice. Oh, I like that.
And it is nice and clean and simple.
Is it really smooth? Looks very smooth from the camera.
This one is actually extremely smooth. Let's see if we can get a
Nice.
zoom in on that.
Mm-hmm. Yeah.
See?
Yeah, it looks
Very
great.
high quality. And I can do gears, I can do toys, I can do all sorts of parts and all sorts. And I've got a whole pile of fun stuff. The other thing that's nice about this is that you can do, you can make, you make ideas a reality. I wanted to make a bracket so I could have my iPhone stick to my mirror. Because I wanted to watch the news while I brushed my teeth. Right?
Serious problems that we're solving here.
Yeah, these are first world problems, exactly.
Definitely.
But I made a bracket to hold my, hold my Raspberry Pi. Or my son wanted to give away heart necklaces.
Aww, to all the girls. Is that what he's doing?
He gives them to everybody, but yeah.
Aww, that's cute.
Something on my 3D printer itself was vibrating on the desk, so I made feet, and then I got rubber feet on the bottom of those pieces of plastic.
So you 3D printed feet for your 3D printer.
Well, here's the other funny thing about 3D printing is that most of the things you will end up printing are to make 3D printing easier.
Oh, like what?
I ended up printing a spool holder because I found when I bought this spool that I didn't have anything to put it on.
Oh, interesting.
So I needed an adapter so then it could spin smoothly.
Very nice.
And I actually wrote that in JavaScript.
Wow.
Which would be nice. So people initially come into this thinking that they're going to have to learn how to draw and do things in 3D.
Yeah.
But with an example like this, I use a thing called JSCAD and basically wrote a union between a cylinder and a conic shape and described that entirely in JavaScript. So I can show you how to do that kind of stuff.
Okay, I have so many questions.
Please.
Okay, I'm going to start at a little while back when you were describing the filament, I believe is what it's called, and then it melts and it kind of goes through a needle thing. So is the idea that you start with this solid spool of stuff, you melt it, and then you're basically kind of drawing like lines, and the idea is it's still liquid at that point, and then it solidifies, and that's how it becomes a layer?
It comes out. Let's do this. Let's try this and see if we can ask and answer that question. So here is a picture of my printer. It is called a PrinterBot Simple Metal. It was about $599, and I got it on Amazon. And if you check out our previous stuff on the show, we had Mark Brooke Drum, the CEO of PrinterBot. He came on the podcast. It looks exactly like this. It is probably smaller than my actual printer. Okay, so you can go up to PrinterBot. There's a fancy version that you can get that looks like this, and this is the extruder, and it's wrapped in insulation.
Okay. And that's the thing that does the melty stuff.
Exactly. The extruder does the melting. So I hooked up a Raspberry Pi, and let's switch over to that. And here is a live camera. There's my hand. This is really happening. And here is the extruder. Now, this extruder is off, so I am going to turn it on and change the temperature. So here is a chart that shows the temperature. I'll set it to 200 and hit set. And that's going to go and send a command to this over a serial port. This is actually just a little Python web page running on a Raspberry Pi, and it's plugged into the device. So here we can see the target temperature has just raised up to 200. So we're heating up the hot end.
Yep.
And you see right here where it says actual? That's going up. Now if I switch to terminal, we can actually see the terminal conversation. It's kind of like in the old days when you talk to a modem. There's your temperature right there, you see? That's updating. So it says M105, which means what's your temperature? And it says I'm 83 and I'm on my way to 200.
Nice.
And now I'm 98. So you see it's heating up very quickly. And then the little chart here is getting generated for me.
Now, do you need a Raspberry Pi to do this, or can I do this on just a regular computer? Or
Great question. So there is a program that's called Repetier, or Repetier. I don't know how to pronounce it. I'll show you what it looks like. So this is an app I'm actually running on my Windows box right here. This runs on Mac and Linux. and I can go into here and I can manually control my printer. I can just plug my printer in with USB. Oh, I'm sorry, I didn't switch. There we go. Pardon me. So here's the application. Again, I'm not quite sure how to pronounce it, but Repeater
we'll have it
or
up on the side.
And I can control it X, Y, Z. I can drop my objects in here, and I can also print on an SD card. So it's kind of like, you know, those printers where you can, like an inkjet printer. I can put a JPEG on it, and it will print the JPEG, or I can print the JPEG from my computer. So you've got a couple of choices here. You can just run this app and print from here, but printing takes 4 or 5 hours. I didn't really feel like sitting there and letting my computer be used for 8 hours, so I thought it'd be a good idea to get the Raspberry Pi.
Yeah.
And we're actually going to have Gina, who wrote this application, Octoprint, on the podcast later in the...
Oh, very cool.
Yeah. Oh, okay, look, so the temperature's coming up now, 195 Celsius. So I'm going to switch over to control here. And I can actually control this.
Oh, cool.
Now I'm going to lift it up a little bit.
Okay.
And then check the temperature again, and we're going to extrude the stuff out of here. Now, this is hot. That is, 400 Fahrenheit. There we go. We are at 199 now. Okay, so I'm going to hit extrude, and we should see it come out of here. And let me add a little bit of light. There we go.
That looks good.
You see that?
Yeah. So that's the filament that we saw, and now it's it looks melted and kind of sticky.
Yeah, so I'm going to touch it, and I'm going to pull it right out, and I'm going to bring it over to the screen now. So let's take a look.
Oh, it got hard already. Wow.
It is quite hard, in fact.
Yeah. Is it rubbery? Is it like bendable?
It is bendable.
Okay.
But it is literally getting colder as we speak.
Yeah, that's really fast.
Yeah. But if I fast forward to something like this, there is bendability there. But if I show you this guy, that ain't going anywhere.
Yeah.
Right?
So is that just about the thickness? How many layers are in it?
Exactly. So let's switch back over and look at it again. And they give you a little cube. They call it the first cube. .g. I'm going to open that up. And it says here the machine is operational.
Okay.
And it's going to take 7 minutes to print this. But we can actually go into the G-code viewer. G-code is the word for the code that describes how to talk to the device. And I'm going to go and center and zoom in. So this is the first layer of the cube that we're going to build. And it literally shows you how it's going to move. It's going to move, it's going to go here, and then look.
Oh, that's so interesting.
Isn't that crazy? So I can actually switch from layer to layer and show you each layer all the way up. Okay? So let's try this and see if it works. And we'll only do a couple of layers in the interest of time. Now it's heated up, which means we should be able to just go... Oh, actually, I need to center it, meaning I need to tell it where 0 is. So this guy here on the right is an optical eye. It's going to stop when it sees this. Now you notice that I put tape down. That's because it needs to be sticky. Yeah, you want a base that's sticky. So now it's going to look at the corners, and this part took me a long time to figure out. It's moving the entire thing around, and it's checking in all of the corners to see if the table is level.
Oh.
Because
what happens if it's not?
Yeah, well, it might be off by a millimeter on one side, right? So then it will adjust automatically.
Oh, okay.
It realizes that it has to adjust when it's on the far side. Now, right now, you know how if you're writing a check or you're starting out with a new pen, you're going to scribble first. It is scribbling right now on the page just to basically test that out.
Yeah. So when you said earlier that it failed, is it the printer knowing that something went wrong and stopping, or is it you checking up on it and realizing something was wrong?
Yeah, that's a great question. So this actually took me a while to figure out. It turns out the printer is so dumb.
That's not what I was expecting.
No, I'm telling you, I thought that I was going to like give it a 3D model and it was going to magically do 3D stuff.
That's what I thought too.
Yeah, the printer knows nothing about anything. If you switch over to the terminal here, look, all the printer knows is go here and then go here and then go here. Like these are the steps. You see the numbers of the steps?
Yeah.
Go here, go to X, Y, go to X, Y, and it move around. That's all it knows. We can actually see here it happened. Look at that.
Oh, yeah. This is real time, right?
This is real time. This is the instructions that it's sending. So we are seeing the G code. So the part that took me a while to understand, and what I hope our code newbies will appreciate, is this idea that the 3D model gets sliced. It gets chopped up into pieces, and the pieces are each layer. So here we've done how many layers here? We've gone 1.5 millimeters. Okay, and we've printed that little bit, and I can go down here and see which layer we are on. See, there's 39 printed layers.
Yeah.
So it'll go like this for another little while. I'm going to go ahead and stop it. I'm going to hit cancel. And cancel doesn't happen immediately. So if I come in here and find that it's gone all wrong, there's a buffer. So I got to stop it, right? So now I'm waiting for it to cancel, and these buttons are going to turn back on. Notice that the fan turned off.
Yeah.
The fan is actually blowing right down there, and it's just literally blowing on it to get it to cool faster.
Oh, interesting. Is that something that you have to control too? The way that you do the temperature? Yeah,
I'll show you. Actually, you control it in the G code. So now I'm going to go and scrape that off. And what I'm going to do is I'm going to take literally just a scraper, like you would use to scrape your tile or something. Okay, there's the edge. This part didn't matter.
Okay. So that's the scribbling part that you were talking about?
Yeah, that's just to make sure that it's coming out. This part is always so funny because you end up, look at that. It looks like you're destroying it. Yeah, well, it's got to stick, right, or it's not going to work.
Yeah.
Okay, now let me switch the camera back over to here. I need you to close the door, buddy. I'm recording a show. Goodbye. Close the door. I'll talk to you later. So here, let's see if we can get that to focus again. We struggle with the focus. So there we go.
Nice. That was really fast. That was a lot faster than I thought it would be.
Well, it's fast, but it depends on what you're doing, right? Yeah. So in this case, this is an unimpressive piece of plastic here.
I think it's a magnificent square piece of plastic.
You like that?
Personally.
Fantastic square.
I think it's
I'm going to switch to the other camera because getting these things to focus close in is such a challenge.
Yeah.
Try over here.
Yes.
There we go. Now we're talking. Look at that.
All those lines.
That's exactly what it said it was going to do. Now here I stopped it. Look at that.
Oh, very cool.
Why does it have a lattice work? Why isn't it solid? My question to you.
Because does it have to go back and fill it in?
Well, does it need to fill it in?
I guess not.
Like Groot. Remember Groot. Does Groot need to be a solid piece of plastic?
No, I guess it doesn't. So does it only do it on the most outer layer? Is that the only layer that it cares to fill in?
Yeah, so it actually turns out that you can decide. You can decide how you want to do it. So let's switch back here and look at a model, and we'll walk through the process. I won't actually print for 8 hours because that'll bore you. But what we'll do is I'm going to share my screen again, and we'll grab a model and go all the way up to the point where we'll start the print. You know what I'll do? And I'll let the print run, and then when we blog about this experience, we'll share it. So you go to Thingiverse.
Such a great name.
This is like the Wikipedia of parts, and you can say, you know, I really need to generate my own nuts and bolts or my own Dorabots. Look at these.
What are Dorabots?
Just cute robots.
Okay. Like adorable robots?
Yeah. I want to make a little robot kitty. Or I'm sure you heard about the little robot arm that Iron Man gave to a little boy, so you can print your own hand.
Oh, that's so cool.
Right. So let's say I wanted to print out this hand. Well, that's the result of the picture, but in fact, it's going to be multiple pieces. So I got to come down to the instructions here, and they'll explain to you about how to actually make it, because you can see it includes some bolts and some rubber bands and things like that. I can go to Thing Files. Here we go. Look at this. Each piece is a different file, right? So right fingers, left fingers, the body, the hinge, things like that, right?
Yeah.
So here is a hand body. I can then click on that, and I get what's called an STL file. Now this STL file is in fact a 3D file. It knows about 3D. It is 3D. So I'm going to go over to my downloads, and I'm going to drag that into my 3D Repeatia here. So there you can see a hand, right? That's looks like it's
one unit.
One unit, and I might have to run multiple units here. I can zoom in, and I can see the pieces and how detailed the model is.
Yeah.
I can also rotate it or scale it. So let's say this is for a child. I might want to scale it down 0.7 or 0.3. Now notice here, it is now bigger or darn near bigger than the space that the printer can move within.
Oh, interesting.
So we're limited to the square that the printer has available to it, right? So you have to think about what you can print within this 6-inch by 6-inch area, and then if you spend more money, you can buy a fancier printer that will have more room.
I was going to ask, how do you know what the actual units are for that?
So when you
see that anywhere.
Yeah, when you set up your printer, you tell it about things like what COM port to be on and what your speed is, and then here, how fast the z-axis moves, where the park position is, and the shape of the printer. So to your point, is it a classic printer? Is it a this printer? You know, how tall is it? Well, I have 150 millimeters width, depth, and height. And because the printer I'm using is a very common printer, these values were kind of standard. You can go and download printer settings. So there's actually 3 settings that you need to think about. There's the printer and how it is shaped. There is the filament, and then there is the slicing settings. So let's actually not do this hand, because I'm thinking that's kind of freaky looking.
The hand body.
If I needed a hand, let's try something a little bit more fun. Ooh, look at all this. So there's so much cool stuff up here.
There's a lot of stuff, yeah.
Let's do a bolt.
Okay. Practical. So I like it.
I'm very practical. Here we go. So here we've got threaded nuts, robots, and all kind of stuff like that. Here we go. So let's grab one of these. There is the model. I'll go to Files. I will then download that bolt. I'm going to then take that file, again, drag it right there. Okay. Now, I'm going to use a thing called a slicer. This is a 3D model. It is not a description of how to move a printer. Here, I have settings, and I slice it up into pieces, and I say, does it need any support? Like, is this just going to print as it is, or does it need... If it had a piece hanging over the end, like the handle of a cup, I might need to build support, right?
So that's something that you would have to figure out, or would that come as part of the file?
I'll show you. So there's on my website, I talked about a printer shootout I did with a much more expensive printer, and we printed out a cup. Look at the support right there.
Oh, wow. Yeah.
So we needed to have support. Otherwise, this would just melt and collapse on itself, right? So here, I don't think that'll need support, but I don't have to decide that part. They will decide for me.
They meaning the people who made that file?
I'm sorry. The printer slicer will say, if you need support, we'll give it to you if the angle of overhang is over 30 degrees.
Nice. So it'll figure that part out.
It'll figure that part out.
Nice.
So here, I'll just say simple metal, and then the infill question. How much do you want on the inside of this thing? This is a nut. This should probably be kind of, it should have some insides. It shouldn't be hollow. You know what I mean?
Yeah.
So then I hit slice. Now watch very carefully. The model is going to disappear and then reappear. And now, look.
Oh, I see little lines.
It is the actual, how is it going to move? And I can go like this and actually show you the travel moves again. Here's how the printer's going to move. How long it's going to take. It's going to take about 20 minutes. I
155 layers. Those are those slices.
I can actually lower the infill. I'll make it a little bit less dense, and we'll see if it takes less than 20 minutes. I'm going to redo it. Now it's 18 minutes. So I have to ask myself, well, do I want a really sturdy bolt, or do I want one that is just, you know, going to make the point that we're going to make? So here now, if I go to G-code editor, this is the result. This is the how to move. So line 3. Make the temperature 195. Go to X0 and Y0. Turn off the fan. And then look, there's all the moving around, right?
So that information, like, you know, what temperature should it be, does that come from that file, or is that taking it from some other configuration that you set up?
Fantastic question. That is part of the slicer. So I described the printer and then what kind of filament I want to use.
So it's based on the filament type.
Right. So here I said I want the printer to be 195 degrees. And then there are more advanced printers than I have that lets you also have the bed that the object sits on heat up as well. So it keeps it kind of toasty so it doesn't melt and warp.
Interesting.
So you've got your filament settings, and you've got your printer settings, and you've got your slicer settings. So now I'm going to take this code that was generated from the result of the slice, and I'm going to save it. And I'm going to put this in a G-code file. It's just a text file. So we'll call this bolt1. I'm stuck it on my desktop. So now I'm going to use the Octoprint application, and I'm just going to reload that and drag that text file right there. So now it's uploading. Okay, and there's bolt, you see? Hit open. There's the bolt, and I can go back here and see there's that viewer, and we can see what it would look like to make that bolt.
There, can you zoom in?
Yeah, let me zoom in on that. Good point.
There we go. Nice.
So now
that circle is that scribble that you talked about.
Exactly. Nice. And look at that. You see there's the screw mechanism. So let's actually try printing that. Actually, why not, right?
Yeah, let's do it.
Oops. Now notice this. It's running, but I'm going to rush over here real quick because I'm looking and I'm seeing that the tape is kind of lousy. I've ruined that tape. And let's see if I can do something I should not do. I'm going to try to replace that tape while we wait for it to heat up.
Oh my goodness, risky.
Phenomenally bad idea.
You are such a daredevil.
Well, you know, that's how we roll here on Marches for Makers. You're going to burn yourself. You do it for the people. Right, because we love you guys so much.
I think that's our new slogan.
Yep, if you're going to burn yourself,
you do it for the people.
Burn it for the people, yeah. Oh, that is hot. So, if I had a nicer situation here, if I had a nicer, more expensive printer, I would have a heated bed, and I would print on that very nice bed, and I would have a piece of special tape. But I'm just using blue painter's tape here. Okay. So now we're waiting. Why? See our print. Look at our heat.
Yeah, we have to get it to heat up again.
Heating back up again.
Yeah. So it cools down pretty quickly.
Yeah, it actually does. Surprisingly, there's it's 200 degrees. It's kind of like opening your oven. 400 degrees is super hot, but it's not going to be hot for hours and hours.
Right. So that file that you had, the .stl file, can any 3D printing software open that, or is that specific to what you're using?
That is a brilliant question. You can actually, I think, STL files. You're going to love this. Can be viewed on GitHub now.
Oh, very cool. I do love that.
Yeah, so check this out. In 2013, GitHub added support for viewing STL files directly in GitHub because they're just text also.
Wow. Oh, that's so neat.
Isn't that great? So I can go up here and find some parts. Let's find a pulley. There's the Git. Look at that. Now we're on GitHub, and it's source code. It's source code, isn't it? So why shouldn't it be treated as source code? And then open JSCAD. Get the printer going there. Open JSCAD. I was saying I could do things in JavaScript before.
Yeah.
Check this out. That, all done in JavaScript, is this piece here.
What?
Now,
That's crazy.
It is. Now you remember this object, right?
Yeah.
This is the one I made to fit the filament. I made that because I saw a problem and I wanted to solve it like that. Let's do this. Let's go Anselman 3D JS CAD. This is what's a reason to have a blog, my friends, is so you can Google your brain later.
Yes.
There's my code, my JavaScript. Okay? I'm just going to paste it in here.
You can't see.
Oh, sorry. I'm going to paste it. Whoops. I'm going to paste it back over here.
There we go.
And let's see, what do I need to do to make it go again? How do I update you?
Is there a run?
That's my next question, isn't it?
Yeah.
Find. Come on, OpenJS CAD. Let me do this. I'll bring it into Notepad and then just take the one function. All right. How are you going to update?
You have to do generate? Yeah.
No, that's not it.
No, that didn't do it. When you press enter, anything happen? No.
Oh, there it is. Shift enter.
Shift enter, nice.
Ah, look at that. That
so
is the thing I told you. And then look, and then this is the thing that's so crazy about 3D printing. And then I made it. I made that thing. You know what I mean? Like, I know I could have gone into a 3D printing application and I could have, drawn it. But I knew the measurement, and I knew it because I got a little, tiny millimeter ruler, what's called a pair of calipers, and I measured it, and then I just said, as a programmer, I think our brains work differently, and that makes more sense, doesn't it?
Yeah.
This height, that radius.
Yeah.
Now you hear that thing running in the background there. Let's go look at it. So it looks like it is printing the bottom of that bolt. I'm going to have my own bolt. I don't think it's going to be a super awesome bolt.
It looks like it's going to be kind of big, too.
Yeah. This is the thing about 3D printing also, is that you don't necessarily have to print plastic.
Ooh, what else can you print?
Chocolate.
No way. Don't do that. No.
Yeah, actually, it turns out it's a totally huge thing. Printing chocolate with 3D printers, it's really, really popular. Check this out.
Oh my god. Oh my god, it's so pretty.
Look at the little 3D printed dog.
Oh, that is
And
adorable.
it makes total sense, though, doesn't it? Like, let's look at this picture.
It does.
It's
it makes a lot of sense. Yeah.
So 3D printing sugar. Now here's where your brain explodes.
Uh-oh. I don't know if I'm ready. What? What does that even mean? Like real wood?
Yeah. They chop it up somehow, and then they turn it into extrudable stuff, and you can 3D print stuff with wood.
Wow.
And then the other thing about 3D printing, kind of to end on here, is that there's a new thing that just came out that is the a different non-extrusion based 3D printing from a company called Carbon 3D. This is a whole new way of thinking about 3D printing. Let's see if I can see a Carbon 3D example. Carbon 3D example. This is more like Terminator. Remember when they came out of when the Terminator came out of the pool of goo?
Holy crap, this is happening. It's a great video.
Yeah, I would actually like a video. Holy crap, this is happening may not necessarily be. There it is. Watch. So there's the goo.
Yeah.
And it pulls it out of the goo.
What? I don't.
That is 7x speed.
What does
so
that
it's a
even
little.
mean? What is happening right now?
It's got lasers that are pointing at the bottom, so this is actually not appearing at the top. It's appearing at the bottom.
Okay.
And it's saying you're going to stick to this point, and then it pulls up a millimeter or two, and then it gets the rest of the goo. So it's using the goo as a reservoir from which to pull from.
But what is the thing that's making the shapes?
There is underneath here. There's like a laser dealy. I don't know. This is very scientific, of course. You can tell I know exactly what
laser
I'm talking about.
Laser
dealy. Lasers and light that are encouraging this filament to attach, and then it pulls it up.
That is amazing.
Yeah, so there's a lot of different ways. This is, I'm showing PLA extrusion, basically the cheapest, simplest, hobbyist way. But the other thing I tell people about 3D printing is you paid $400 for an Xbox. Why are you not going to spend $500 for a 3D printer? Right? Why not just go for it,
I think a 3D printer is more impressive. Like, if you want to show off to your friends and family, I'm just saying.
Yeah.
I think you look a lot cooler with a 3D printer.
It is much easier than you would think, but at the same time, it's a hobby, and hobbies suck money.
Mm-hmm.
That's $30. You know what I mean? So you might make fun little toys. I think where the boys and I made. Where's our fun little toy that we made? I think I showed you the useless machine, didn't I?
You did, but I'd love to see it again.
Where is the useless machine? I think one of the children snuck in here when we weren't actually looking.
Oh.
Sorry, I can only show you Groot, but yeah.
Groot is pretty awesome.
All sorts of cool stuff. I mean, this is the other thing that I think people forget about is with 3D printing, you go to the conventions and they've got little cute Pokemon or whatever.
Yeah.
Right, that's lame. What I think people need to do is solve real problems with 3D printing. So on my Instagram, I've got an example of one problem that we had in our house, which was that I wanted. Oh, there's the. Here you go. Here's the impossible machine.
Or the useless machine.
The useless machine. You turn it on, and the little finger comes out and turns it off. He desperately does not.
It does it really fast too.
Yeah,
wow.
I overvolted it.
It's very persistent about not.
It indeed is.
Not being on. Yeah.
Here's the problem that I solved though. I wanted to hang up my handheld vacuum cleaner, and it did not have a bracket. So I found one, and now I can plug my vacuum in.
Very nice.
Little stuff like that. It's made me happy. I made a vase.
I like that.
We made we made cups.
So when you say that you made these things, are you using JS-CAD to actually design it and figure it out and then printing it?
So I would say about 70% of the time I'm finding other people who've done the work for me.
Okay.
And I would say that 30% of the time I'm doing it myself.
Okay.
I think you can spend a lot of time designing.
Oh yeah, I bet.
Another great website is Tinkercad, which is literally letting you draw the 3D objects in the browser without using JavaScript. I think that using JavaScript is a lot to ask.
Yeah.
I don't think Mom and Dad want to do that, but Tinkercad is something that you can do. Oh, and the other thing that's fun about 3D printing is that you don't need a 3D printer to do it.
Wait, what does that mean?
You can make something like on Tinkercad, and then a website called Shapeways will print it for you and mail it to you.
Oh, very nice.
Yeah.
Oh, that's really encouraging.
So this is all in the browser using the magic of HTML and whatnot. So I can go and say create new design. Here we go. Drag, make a box and put a box over here, and then from here, all again.
Oh wow, that's really easy to use.
Yeah, well check this out. I can bring this over, and let's say I want to make a hole in my box. I'll change it from an object to a hole. Now I'm going to group them together. Okay. And now I've cut a hole.
Very, very cool. So have you ever used Blender or anything like that?
I have not. I have seen it though. I've seen it. Is that something you've used?
I have, just a few times, and it's very, very difficult to use. And that is, if I wanted to create what you just did in Blender, it would take me like an hour. So
well, what's great about Tinkercad is that at this point I can send that off to Shapeways, and I can get that done and sent off to the people. So there, look, my screw there is, or my bolt is working. I think it's going to happen. Actually, I'm going to stop that because I think that'd be a good place to stop. I don't want to let it go too long. I don't really need a bolt in my life right now.
No, not that size either.
No, and I really want to see it. But big things like Groot take 5, 6, 7 hours. So let's pull that off.
Oh, they're back.
Can you step out, sir? We're doing a show. No, sir. Goodbye. Sorry.
That's okay.
This is a fun episode. Here, take a look at that.
Nice. I might want to put on the other camera to.
Yeah, I'll put that on the other camera. So let me switch over to the other camera.
Yeah.
And here we go.
Nice.
Let's see. Let me zoom in here. Come on, focus.
Almost, you can do it.
You can do it. Almost there.
Almost.
I need to learn how to make webcams focus close in. Because people are going to say, that was a really great hour show. 50 minutes of focusing time, though, was a little...
Oh, there we go. That's better. It's getting there. Yeah, that looks great.
Yeah.
Oh, it's one of those little grooves and everything.
Yeah, I mean,
That's
I question if it would be completely functional, but I certainly think you could certainly build stuff with it. You could fix a kid's toy. You could fix a remote control. You know, I don't think you're necessarily going to put it in your car, but you could model it, take it to a machine shop, and they could print one out of aluminum or steel.
True.
Yeah, so there are other options for you to 3D print in. You can practice the prototype in plastic and then move up to another device as well.
Definitely. So you use JavaScript in JSCAD to build your spool holder, I don't know if that's the right word.
Yeah.
And I'm wondering, are there other parts of this process where programming comes in? Like for a lot of people watching who might be coming from software, is that primarily the place where you would use it, or are there other parts of it that's very software programmy?
I would say that if you have a part that you need that is very regular, then you should program it. So gears, anything where there's repetitive stuff, like it would be silly to try to model this screw or this bolt in a modeling tool. You would want to describe that in code and then make it a function. So that you could say, I made a gear. Okay, well now I've got the variable for the height of the gear and the number of teeth and the width of the teeth and the depth of teeth, and then code that. So regular looking devices. There's actually a fellow who wrote he created a model of an engine, and I believe about half of it was generated while half of it was modeled.
Oh, so you can mix them up too.
Of course, because the result is an STL file.
So however you get there, it doesn't really matter.
Exactly.
Very interesting. And the other thing that surprised me is how much manual stuff you kind of ended up doing. Like you set the temperature based on the filament that you were using, and you had to kind of make sure it was positioned the right way. How much, I guess, time or effort does it take to figure out those manual parts, and how much of it is just kind of hands-off?
I started 7 out of 10 prints were a fail, and now 2 out of 10 prints are a fail.
Oh, wow. Okay.
Yeah.
So a lot of learning just on your part.
Absolutely, and seeing it twice. Like you have to make a mistake and then see it again. So, for example, those ones that I showed you before, where there was a space between something, I sat there and I actually thought, and I said, I think the heat is wrong. And then I stopped the print and I raised it 5 degrees, and then it worked.
So it was just trial and error for you.
Yeah, but also keeping notes and keeping track of that kind of stuff. But looking online, and you might say, I have stringy prints, and then there's a website that says stringy prints. More.
Interesting. Okay, and so for that one, when it failed, it was you looking at it and saying, wait a minute, this doesn't look how I want, let me stop it.
Right.
And you were able to identify it even at that level?
I was able to know that something was wrong. I definitely know when something is wrong. I'm still not 100% sure. Like, one of the biggest problems I'm having is stickiness, and that was literally just trial and error, and it was switching brands of blue tape.
Oh, interesting. So what brand worked for you?
I tried Scotch, and it was very waxy, and then I switched to Uline, and it's very tacky. Some people also put hairspray on it, and that is to keep the thing sticking there because it's moving around. And if it just slides off, the printer doesn't know it slid off. It's just going to start printing crap, and you'll end up with a big bundle of plastic goo, a bunch of crap.
Bunch of crap. We don't want a bunch of crap. Okay. Now I'm wondering, when you first started, what was the biggest learning curve for you? What was the hardest part?
What was the hardest part? I understood the setting up of the machine and the USB and the drivers and that kind of stuff, and most of that's pretty straightforward now. You can buy one of these printers, plug it into Windows 8, the drivers are built in, there's no installation. It was more, I didn't think I'd have to tweak it so much. Like the air conditioner, like, don't turn the air conditioner on. Why would you think that,
Yeah.
Stuff like that was extremely extremely confusing. I also didn't realize that bumping them was such a big deal.
What does that mean?
1 millimeter. Like if you
literally bumping it,
then the entire top layer might shift by a millimeter. And if you think about what we were trying to do here, right?
Yeah.
A single millimeter shift is going to make what was a nice gift turn into a bunch of garbage.
Yeah.
What do I got in here? Oh, I know what I'm doing. My son and I are in the process of building an Optimus Prime transformer that turns into a TARDIS.
Nice.
This is the top of the TARDIS, and he'll transform into Doctor Who's police.
I feel like you guys have tons and tons of fun.
We do have fun. Honestly, if you have any expectations at all that you're going to make amazing things and make $1 million, it's not going to happen. But if you are going to have a blast and you look at it like woodworking or something like that, then you're going to have.
Or chocolate, eating interesting shapes of chocolate. I'm just saying that's really all I needed to get started.
We could have saved a lot of time if I just said at the beginning. We're making chocolate today on March.
Exactly. That was awesome. That was a really great intro. Scott, any final thoughts or final words before we wrap up?
No, just know that the 3D printing community is really, really welcoming, and there are also meetups near you. I went to one here in Portland. I went to meetup.com, and there were some 3D printing people. There were old people and young people and kids and people trying to do all sorts of stuff.
Ages.
I saw people from the local theater group who are now using 3D printing to make props for costumes.
Very cool. Yeah. Oh, I like that. I like that because you get to not just do something for your own home, but you get to kind of share it with everybody, too.
Absolutely.
Everybody gets to see it. That's great. Awesome. Well, thanks to everyone who joined and who's tuning in and hopefully watching it. And hopefully we'll do another live tutorial of some other maker-type thing next week after that.
Yeah, I hope so.
Awesome. And don't forget to check out marchesformakers.com for all this awesome content. Thanks so much.